In today's lecture, we're going to explore the fundamentals of Python syntax. But before we dive into writing code, it's essential to understand how Python executes that code. Specifically, we'll look at the two primary modes in which Python operates: interactive mode and script mode. Interactive mode, immediate feedback. Interactive mode allows you to enter Python commands one at a time and receive immediate feedback. This is incredibly useful for testing small pieces of code or experimenting with new concepts without the overhead of writing an entire program. Good for testing small code snippets. For example, if you're unsure how a particular function works or want to test a snippet of logic, you can do so quickly in interactive mode. It acts like a powerful calculator and scratchpad for code. How to access interactive mode. You can start the Python interpreter in interactive mode by simply typing Python or Python 3 in your terminal or command prompt. You'll see the Python prompt indicating that you're ready to start entering commands. As you can see, each command is executed immediately after you press enter, and the result is displayed right away. Script mode, running programs saved in files. Script mode involves writing your Python code in a text file, typically with a .py extension, and then running that file as a whole program. This is how you develop actual applications and complex programs. Ideal for developing applications. When you're working on projects that require multiple lines of code, functions, classes, or modules, script mode is the way to go. It allows you to save your code, edit it, and run it multiple times. How to use script mode. You can write your Python code using any text editor or an integrated development environment, IDE, like VS Code or PyCharm. After saving your script, you run it from the terminal using the command python script name.py. Example, create a file named calculator.py with this content. To run this script, open your terminal, navigate to the directory containing calculator.py, and execute. Why understanding both modes matters. Interactive mode is great for quick tests and learning. It's like a sandbox, where you can play with code snippets without worrying about the broader application context. Script mode is essential for building scalable and maintainable code. It allows you to organize your work, reuse code, and collaborate with others. In data science, you'll often use interactive mode in environments like Jupyter Notebooks, where you can run cells of code and see immediate results, perfect for data exploration. Script mode is used when your codebase grows, such as when developing data processing pipelines or deploying machine learning models. When to use each mode: interactive mode, testing functions or small code snippets, performing quick calculations, learning new Python features. Script mode, writing full programs and applications, saving code for future use and version control, collaborating with others on larger projects. Additional tips. In interactive mode, remember that your variables and functions are not saved after you exit. If you need to keep your work, use script mode. You can also use both modes together. For instance, test your functions in interactive mode before adding them to your script. To write a Python script, you can use any text editor or an integrated development environment IDE like VS Code or PyCharm. Just make sure to save your file with a .py extension. To run your script, you can open a command line, navigate to your scripts directory, and type python script name.py. Alternatively, IDEs often have a run button that does this for you. Comments are notes in your code that the interpreter ignores. They are crucial for explaining what your code does. In Python, single-line comments start with a hash symbol. For multi-line comments or docstrings, you use triple quotes. This is helpful for documenting functions and modules. Variables are like containers that hold data. In Python, you assign a value to a variable using the equals operator. Python is dynamically typed, meaning you don't have to declare the type of a variable, and you can reassign variables to values of different types. Python has several basic data types. Integers are whole numbers, floats are numbers with decimal points, strings are sequences of characters enclosed in quotes, and booleans represent true or false values. Understanding these types is essential for working with data. Python supports standard arithmetic operations. Remember that Python follows the mathematical order of operations. For example, in 2 plus 5, multiplication happens before addition, so the result is 17. Use parentheses to change the order if needed. The print function is used to display information to the user. You can print literals, like strings or variables. For more complex output, formatted strings or f-strings allow you to embed expressions inside string literals. Unlike many other languages, Python uses indentation to define blocks of code. This makes code visually clean but requires attention to detail. Indentation must be consistent, otherwise you'll encounter an indentation error. To get user input, use the input function. It reads input as a string. If you need another data type, like an integer, you have to convert it using functions like int or float. Good coding practices make your code readable and maintainable. Use meaningful variable names so others can understand your code. Comment your code where necessary and follow the PEP8 style guide for Python. Avoid hard coding values. Instead, use variables or constants. Let's look at a simple example. This program asks the user for two numbers, adds them, and prints the result. Notice how we convert the input to floats and use an f-string to format the output. Errors are a part of programming. Syntax errors are the easiest to fix once you understand Python's syntax. Runtime errors occur while the program is running, and logical errors are the hardest to catch because the program runs but doesn't do what you expect. To wrap up, we've covered the basics of Python syntax, including variables, data types, operations, and basic input-output. Remember, practice is essential. Try writing simple programs to reinforce what you've learned today. Please make sure to complete the reading assignments, as they will reinforce today's lecture.